Okay, and now let's do problem number 4 on page 5 in its entirety. So it says you're pulling a 196 Newton box across the floor, accelerating at 3 meters per second squared. Given the coefficient of friction between the box and the floor is 0.3, calculate the exerting force. Okay, so it looks like that we're pulling a box across the floor. And it looks like that it's accelerating. Okay, so let's just do this here. And it says that we're pulling it across the floor. Okay, that's going to be our applied force. And we have our frictional force. Being that we know that it's accelerating, we're going to say that this is kinetic friction. Okay, we have our free body diagram. Now let's pull out our given information. You're pulling a 196 Newton box across the floor. Okay, so that sounds like our force due to gravity acting on the box is 196 newtons. And it's accelerating at 3 meters per second squared. And I would actually say that it's accelerating in the x direction. Given the coefficient of friction between the box and the floor is 0.3, okay, so that's our mu k is equal to 0.3. Calculate the exerted force. Okay, and I believe that's all the information that we're given here. So, looking at this, let's calculate what our mass is. Okay, so all we have to do is a division of 9.8 on both sides of the equation to get our answer for our mass. Okay, and I have a mass of 20 kilograms. Now let's set up our two force equations. Alright, and we're just going to say all the forces going upwards are going to be our positive, and all the forces going to the right are going to be positive. We're doing all the forces going to the right because the object is moving to the right. Okay, so all the forces going up minus all the forces going down is equal to mass times acceleration in the y direction. This is not moving up or down at all, so we know that the acceleration in the y direction is 0. 0 times any number is equal to 0. Okay, and all the forces acting to the right minus all the forces acting to the left is equal to mass times acceleration. We know that the object is accelerating, so therefore all we're going to do here is just drop this information down. Okay, and it looks like that I want to be solving for our applied force. We have applied force over here, so I'm just going to be working with this equation for now. Minus our kinetic friction. I don't have kinetic friction over here, but I do have coefficient of kinetic friction of 0.3. And we know that the kinetic friction is equal to mu k times Fn. Well, being that I do have our mu k over here, instead of using Fk, I want to be using mu k times Fn. So I'm just going to do this simple substitution. And that's equal to our mass times acceleration in the x direction. Okay, so once again, we're still solving out for this, so let's continue this. Our mu k is 0.3 times our Fn. I don't have Fn over here, but I do have it over here, so we're just going to be using that. Fn minus our Fg is given information. Adding 196 to both sides of the equation, we have Fn is equal to 196 newtons. Okay, so I have our 196 over here times is equal to our mass of 20 kilograms times our acceleration of 3. Okay, so we have our applied force minus, let's just do this calculation over here. And 3 times 20, simple enough, is a value of 60. Okay, and all I have to do here is just solve out. And that is problem number 4.